to minus x, this into this, minus minus become plus, this into this, x e raised to minus x e raised to minus x, and then is equal to this x e raised to minus x into e raised to minus x is e raised to minus 2x, plus this is e raised to minus 2x, plus x e raised to minus 2x. This is minus sign, here is minus sign, so we have here minus this into this. So this is equal to e raised to minus 2x, and this is not equal to 0 quantity. This is non-zero quantity. This is always non-zero for all x. That is, if x is 0, then also e raised to 0 is 1. So this is not equal to 0 for all x, and therefore these y1 and y2 are linearly independent. These y1 and y2 are linearly independent. So if the question is show that y1 and y2 are linearly independent, so what is its answer? Show w of this y1 and y2, that is Dvorskian of these two, is not equal to 0, and therefore these y1 and y2 are linearly independent. So these are the two linearly independent solution. One of them is y1 and another is y2. And then next, put y is equal to y1v, and therefore y is equal to y1 is e raised to minus x v. Either take this x e raised to minus x is equal to y1 and e raised to minus x is y2, where v is what? Function of x. Then y dash is what? E raised to minus x, by using u into v rule, v dash plus e raised to minus x, derivative of e raised to minus x, e raised to minus x into minus 1 into v, that is e raised to minus x v dash minus e raised to minus x v. And what is y double dash? Is again u into v rule, e raised to minus x v double dash plus derivative of e raised to minus x is this, minus in bracket e raised to minus x v dash plus e raised to minus x into minus 1 v, u into v rule for this. So we have e raised to minus x v double dash minus e raised to minus x v dash minus e raised to minus x v dash, minus minus become plus e raised to minus x v, and this is equal to e raised to minus x v dash minus 2 times e raised to minus x v dash plus e raised to minus x v. So putting y dash and y double dash in equation 1 we get. So what is equation 1? Is the equation 1 is what? This is equation 1. D square y. What is d square y means what? Y double dash. So its value e raised to minus x v double dash minus e raised to minus x 2 times v dash plus e raised to minus x v. This is what? D square y means y double dash. What is this? This is y double dash plus 2 y dash plus 1 is equal to 1 by e raised to x minus 1 bracket square. This is equation number 1. Y double dash d square y means y double dash plus dy means y dash, and plus 1 into y means y, 1 into y means y. So y double dash plus 2 times y dash. So y dash is what? This e raised to minus x v dash minus e raised to minus x v plus this y plus y means y1 v is equal to RHS is what? 1 by e raised to x minus 1 bracket square. So this is equation number 1. we have this. Then collect the coefficients of v double dash v dash. So what are the coefficients of v dash? Minus 2 e raised to minus x and plus 2 e raised to minus x v dash. And the coefficient of v dash, value of the coefficient of v dash is 0. In every problem, the coefficient of v dash becomes 0. And plus coefficient of coefficient of v, e raised to minus x, this term, then this term, plus, not plus, minus 2 times e raised to minus x, coefficient of v. This term, and this term minus e raised to minus 2 times e raised to minus x. V dash, coefficient of v, e raised to is equal to y1 v. V means what? V means e raised to minus x. Y1, the value of y is y1 v. That is what? Y1 e. This is y1 v, e raised to minus x. So the coefficient of v are what? E raised to minus x minus 2 times e raised to minus x plus e raised to minus x. V is equal to 1 by e raised to x minus 1 bracket square. Here write y as e raised to minus xv. And so the coefficient of v dash is 0. Here the coefficient of v is also 0. This is only for particular this example, the coefficient of v becomes 0. But the coefficient of v dash is 0. We have the coefficient of v dash is equal to 0 in every example. So we have this equation, e raised to minus x v double dash. Okay. Then this is suppose this third equation. Then substitute, putting v dash is equal to w, and therefore v double dash is this. So we have this equation, bracket square. This is equation suppose 4, and this is what? This is the differential equation of first order. So the given differential equation is of second order, and it is reduced to first order differential equation, and that's why the method is called reduction of order. Order is reduced by 1. Second order differential equation converted to first order differential equation, and solve this differential equation. That is this equation number 4 is solvable by either variation by using separation of variables, or this may be of the type linear differential equation. Here this differential equation is in variable separable form. Substitute, shift this e raised to minus x. W dash means dw by dx. So e raised to minus x is shifted to right side, then it becomes multiply by e raised to x. So we have this step. This is the differential equation in w and x. The two variables are w and x. So separate the variables. Dw is equal to e raised to x divided by e raised to x minus 1 bracket square into dx. So this equation 4 is what? In this example, this equation 4 is in variable separable form. Variables, when we say the variable separable form, if we separate the variables, there are two variables w and x. So observe this step. LHS of this step is what? Contains terms of w only, and in the RHS contains the terms of x. That's why we say this is the variable separable form. This is in variable separable form, this equation 4. If we cannot separate the variables, it is not possible to separate the variables, then this differential equation is soluble by using the type linear differential equation. We know the linear differential equation. So then integrating. What is the next step? In variable separable form, if the variables are separated, then integrating. So dw, integration of dw, e raised to x minus 1 bracket square, e raised to this term, e raised to x minus 1 bracket square dx. Then the integration of RHS is w, but for LHS is w, but for RHS use substitution method. Substitute e raised to x minus 1 is equal to t, so its derivative e raised to x into dx minus 1 derivative 0 dt. And so we have w is equal to, this is the integration of dw, integration this e raised to x dx is dt, and so 1 by t square dt. So 1 by t square means its integration is minus 1 by t plus constant of integration. Integration of 1 by t square is minus 1 by t, because derivative of 1 by t is minus 1 by t square, or 1 by t square means t raised to minus 2, t raised to minus 2, and the integration of t raised to n is what? T raised to n plus 1 divided by n plus 1. That is what? T raised to minus 1 by minus 1, that is minus, this minus 1 gives minus sign, 1 by t, minus 1 by t is the integration of t raised to minus, that is 1 by t square. Then substitute t is what? E raised to x minus 1 plus constant. So here what we have? W in terms of x and 1 constant. This is what? Linear differential equation, or the differential equation in variable separable form. So after solving this equation, what we get? We get w in terms of x and 1 arbitrary constant c1. So here what we have? W in terms of x and 1 arbitrary constants. Then what is the next step? Then putting w is equal to v dash. Putting w is equal to v dash. What do we get? V dash is equal to minus 1 by e raised to x minus 1 plus c1. So what is v dash? V dash means dv by dx e raised to x minus 1 plus c1. So separate the variables. dv is equal to, we have this, shift this dx, and then integrating integration of dv, integration of 1 by e raised to minus x, this minus n, plus c1 dx. So integration of c1 is c1x, integration of dv is, this integration of dv is the v, integration of minus sign this 1 by e raised to x minus 1 dx plus integration of c1 dx. So v, substitute for this integration, substitute e raised to x is equal to t, and therefore we have its derivative e raised to x dx is dt. e raised to x, dx is dt. So dx is 1 by e raised to x dt, that is 1 by t dt. E raised to x is dt. So we have v is equal to minus sign, this minus sign, 1 by t minus 1 e raised to x is t. dt is what? 1 by t dt into plus c1x plus c2. Integration of c1 is c1x plus c2. Okay, so we solve this integration by using partial fractions. So what are the factors? These are the factors: 1 by t minus 1 minus 1 by t. So t minus t plus 1. So we have this, write this as a by t minus 1 plus b by t, and then we find the value of a. A becomes 1 and b becomes minus 1. This is integration by partial fractions. C1x plus c2. What is this? C2 is the another constants. So here is the sentence. Putting w is equal to v dash in this solution, and after solving differential equation, what do we get? V in terms of x and one arbitrary constant, say c2, different from the first constant. So here is this c2, then v is equal to minus, this is integration is what? Log t minus 1 minus log t plus c1x plus c2, and then substitute this minus log t, substitute t is e raised to x minus 1, minus minus become plus, log t means log e raised to x plus c1x plus c2. So log e raised to x is x into log e. For in next step, this is what? V is equal to minus log e raised to minus x 1 plus x into log e, and log e is 1. So we have this plus x only, c1x plus c2, and these two terms merge in each other. V is equal to minus log e raised to minus x minus e raised to x minus 1 plus this 1 plus c1x plus c2. And suppose this 1 plus c1 is c1 dash x, another constants, where c1 is c1 dash is what? 1 plus c1 is c1 dash, new constants. And therefore the general solution of given differential equation 1 is, what is it? Y is equal to y1 v. That is what? Y is equal to, what is y1? Y1 is e raised to minus x. V is what? Minus log e raised to x minus 1 plus c1 dash x plus c2. So this is what? The general solution of the given differential equation. This solution contains two constants, arbitrary constants, c1 dash and c2, because this is what? This is the differential, the given differential equation is of order 2. That's why this solution, general solution, contains two arbitrary constants. If the given differential equation is equation of order 3, then it contains 3 variables. So this is about the example of reduction of order.